So continuing here on to our next slide, we will talk about the part 3, which is about data visualization with Tableau. And for this we'll be creating few scatter plots and analyzing the scatter plot information. So for the part 3 we have a CSV that we are using to analyze which has sales record information and between 2014 and 2017. And then what we are trying to do is like we need to understand the sales and profits for each category items that are generated between those years in a region. Various techniques of analyzing visualizing data can be used to analyze the data, but I think scatter plot is a good representation of the data set that you are checking, and it provides all detailed information being requested relevant to the sales and profit for items sold for each of the category by the region. So for this we will import the data set into Tableau. Like we'll create as a flat file and import this as a source, and we'll create new sheet and use the data set, and we'll create a scatter plot as a graph here with profit and on our x-axis and sales on our y-axis. And if we range a profit between minus 5,000 to 55,000, and then the sales between 0 to 250k or little over 250k, we have categorized 3 different kind of categories that we are looking at here: furniture, office supplies, and technology. And then we have kind of used symbols for those 3 categories. And then we have region, central, east, south, west, which are color coded, as you can see, between blue, orange, red, and yellow. So based on that information, we can see here how much is the sales like on this scatter plot. For example, so for furniture, how much is the sales value in central region, and versus how much is it for east, how much is it for west, as well as how much is it for south, based on the color codes and then the diagram chart or the symbol type. So this is going to give a very detailed information in a small space, and if we hover over each value, it will show the exact value of the sales that we have versus the profit that we have on each category that we are going to see. So in Tableau, instead of the screenshot, if we go over and hover over one of these values, that would give us an indication or actual value that we can see for that profit versus sales metric. And this scatter plot is a very good representation when we are trying to understand what we have in our data set for the sales record information, and then how each category is performing in each region. And then if particular region has a category that is underperforming or any category that needs a special attention, based on this scatter plot we can show this to the business, and they can get a feel of the data set. And this can be a real good data visualization information that they'll be looking out for, and then they can see how we have each representation that we are doing here, and how this can be extended to multiple regions as well as multiple categories. And then we can also work with multiple different detailed information that we can pull for this scatter plots. Going to the part B that we are going to analyze in our scatter plot for the sales record information, we are again looking at profit versus sales information, and then we also again are looking at category as well as region, and then we also are looking at the segment information. And then we are trying to create more segments, and then very detailed we are going to a level down that we are looking at sum of profit versus sum of sales, and color shows detailed region, shape shows detail about category, details are shown for segment as well. So similar to the earlier chart, we can see for each segment, for each region, for each category, and then based on color coding, based on again detailed information that we can see here, you can see how the sales versus profit was represented for over the years. And then we don't really need to go into the data set again. from here, this chart or in the Tableau, if you hover over the value, you can clearly get an understanding on how the data set is, like what are we trying to get from this data set. So similarly, we can kind of expand this to multiple more detailed information, as well as not just sales versus profit. We can look at the trend between the years, and then how much is a particular section working, and then when the business is trying to capitalize in a particular region for a particular category, this type of charts will give a very detailed information for them, or their focus points are that is how the visualization comes into picture for their analysis. So I think overall, in and all, for the analysis that you're trying to do on sales versus profit, and then using categories, regions, and segments, we can get into a little deeper analysis for this using scatter plots. I think there might be other ways that we can represent the data, but scatter plot on overall is an easier and a better way to understand this data set. Coming to the part 4 that we are trying to visualize the dataset using Python pandas and matplotlib. So we have to create a machine learning exercise here. For that machine learning exercise, we need to import the dataset into Python using Anaconda, and once we have that launch, we'll import the dataset, and then we can analyze the dataset by loading libraries into Python pandas. The first step that we have to do is import Python libraries NumPy and pandas using the commands import pandas as pd, import NumPy as np. And then next step that we have to do is import libraries and modules for data visualization. From panda plotting, for scatter plots, import scatter plots. Matplotlib, import pyplot. So this will give us the other charts that we are trying to understand. We also need to import SCIKIT learn module from algorithm model L for nearest neighbors. So we will be using KNN classifier to understand our data set, and then we also can train the data set, and then we also can test the data set. We can also completely do a whole visualization project here. Once we create the data project, we can as well go and further analyze, not just creating a matplots plots for scatter plot or others. We can actually have the complete statistical analysis done on this data set. That is what we are trying to show here, how we can try and test and validate the data, and then how we can k-fold. For that, we can use sklearn model selection import and sklearn metrics import. So this one we can go in more detailed, not just stopping at the chart representation. We can go into the complete statistical analysis or a data science project for this. So for this analysis, we are going to use a PIMA diabetes information. So we are going to load the data set. We have the dataset on our local machine. We'll specify the location of the dataset file name equal to the local path where we have the file, and then once we load the dataset, we can analyze it. So for that, we need to create a variable df and then pd.read_csv of file name. This will give the information, and then we can read that CSV. And next, we need to pre-process the data. So we need to clean the data set before we can kind of look at exploratory data analysis. That's why we will replace 0 values as missing or NaN are not applicable. So here we have, for the DF that we have where we recorded the data, we have different types of diabetic information, and then we are replacing 0 or np.nan. And then the next thing that we can do is a simple count of each NaN values in each column, and then we can replace that. And then next thing that we wanted to do is perform EDA on the dataset. We need to get the dimensions or shape of the dataset, the number of records, number of variables that we have, number of columns. We can use print df-shape, and this will give an how many columns, how many records that we have, 768 times 9, that is the wall, x to the y axis of the whole grid of the data that we have. And then we can get the data types of all the variables in the data set using print df.d types. That will give the data set, like, is it an integer, is it a string, is it some other type of character. We can get it. And if you wanted to print first few records, like print first 5 records, we can print df.head of 5. That will give us the first 5 records that we wanted to see. And then before we kind of look at the graphs, we can also look at the summary of the data set. Like, we wanted to get a descriptive statistics, like, what is the min, max, average, standard deviation, variance, those kind of information that we can get using print df.describe. That will describe the data set for us. And then we need the class distribution of the data set. We need to group by df-group by of class.size. This will give how many records are in each class. And then next we can plot histogram. For this one, we can use it df.hist, and then we can give the sizing 12 times 8, and then df.hist can be represented using pyplot.show. And then similarly we can also create a density plot using df.plot kind of density, and subplot true, and layout 3x3, and then the other information like Sherix false, legend true, font size equal to 1, and then what is the size of the figure, 12x16, and then pyplot show gives us the density plots that we can look at from this data set. And we can also create box plots, and similarly like earlier, df-plot kind is box this time, and subplot is similar information that we are seeing, and pyplot.show gives us the box plots. For scatter plots, we need to generate scatter plot for each numerical variable attribute in the data set. For that we can use scatter underscore matrix, that function, and df is our data set, and alpha equal to 8, figure size equal to 15. And once we do pyplot.show, it will show us the plot data.